Okay, today's lesson we're going to talk about exponential and logarithmic equations and inequalities. Okay, so this is going to be extension of lesson 5.3. Okay, so in this one we're going to review the properties of logarithms that would be helpful for solving these kind of problems. Namely, on number one here, if we have the same base and different things for the exponents, then they can only be equal if those exponents are equal, right? If x equals y. And the same thing on property number two, if we have logs with the same base, then the arguments have to be equal if those logs are going to be equal. Okay, so in section 5.2, we solved they call type 1 equations where they can be easily written as powers of the same base, right? So we had 125x equals 5 to the x. So that would have been easy to rewrite that as both the powers of 5, right? 5 to the third x equals 5x, and 5 to the 3x equals 5x, and solve that one. Okay, so that's the problems we've done so far. Now we're going to do problems that look like this, or this type of problem, where they can't easily rewrite the powers of the same base. For example, they have 7 to the x equals 12. So there's no way to rewrite those as the same base. Okay, so the general strategy for those is to take the log of both sides and then apply the power rule to eliminate the variable exponent. So we use that. It looks like this when we do that. Okay, so we start out with the regular problem. We take the log of both sides. Now in this example, they took the natural log of both sides, but you could have just as easily, and most of the time, we would write these problems as the common log of 7x equals the common log of 12. It works out just the same, and the answer comes out just the same no matter which log you use. In this example, they chose natural log, but it works the same with common log. Okay, so what they use the power rule right here to change this x, to get this x as an exponent and move it out here. Okay, so that's the whole point of doing that, is to get that x out of its exponent form where it's hard to solve into a form where we can easily solve it. So they put the x out here in front of the natural log of 7, divided both sides by the natural log of 7, and got x equals this over here, which is the exact answer, and you can approximate that on your calculator by doing that. The same answer would have been log of 12 over common log of 12 over log of 7. Okay, would have been the same answer, right? The change of base rule kind of going on there. Okay, graphing, to do this to see the inequalities, right? We can graph this is, one of them is y1 equals the log power, y2 equals 12, where they intersect. You can use your calculator to find that. We get the same approximate solution. So where it's less than is where the graph, all the values that are less than that, and we go from our domain on this one from negative infinity up to 2, and then the other one would be, if it was greater than, it would be from that number to 1.277 out to infinity would be where it's greater. Okay, so that was pretty easy. Now we have some other problems where not quite so easy. So we have different bases here. We have base 2, base 3, and these variable expressions for the exponents. Okay, so these kind of the steps over here on the right that you need to do to solve problems that look like this. Okay, when they're both exponents on each side, you want to take the log of both sides. So it doesn't matter if you use natural log or the common log, and most of the time we're going to use the common log. So the problem will start out like this. We'll take the log of both sides. Log of 2, 3x plus 1 equals log of 3 to the 4. It should be minus x. Okay? So we just did that. So what does that do? Why do we do that? We do that so we can take these exponents right here, this exponent and this exponent, and get them out of their exponent form and write them in front of the logs, right? We use the power rule to do that. So we're going to write 3x plus 1 log of 2 equals 4 minus x log of 3. Okay, so that takes the variable things we want out of our exponents and puts them in front of the logs by the power rule. Then we're going to distribute these terms here, and we get 3x log 2 plus log 2 equals 4 log 3. Oops, I'm writing those wrong. It shouldn't have been base log. It should have been 2 log 3 minus x log of 3. So we need to get all of the x terms on one side. So to do that, we just add this negative x log 3 and subtract the log 2. So it looks like this when we do that. 3x log 2 plus x log 3 equals 4 log 3 minus log of 2. Okay, so we got all the x terms on one side, we got the other ones on the other side. Okay, so now we're going to factor out the x and solve. So these, if we do that, we put the x out here, and this becomes, I put a little paren here, 3 times log of 2 plus log of 3. I keep writing these as bases, but they're not. They're like that. And equals 4 log of 3 minus log of 2. Okay, so I'm going to close my paren there. And when we solve for x, then we would say that x equals, and it's all of this on the right side, 4 log 3 minus log 2 all over 3 log 2 plus log 3. Okay, so you can put all these terms down here, can go into your calculator, and you can get an approximate answer for this. This is the exact answer. It's not, you can maybe fool around with that a little more, but I don't think so. That's the answer for what that exponent has to be for those logs of different bases to be equal to each other. Okay, so here it is written out a little typed out nicely so you can follow along what happened there. Same thing, they got this answer at the end here. So pause the video if you need to look at that a little more. Okay, so this is another one where we have a different type where we have one log. These logs are all the same base, right? They're all base 3, 3, and 3. Okay, so they're log of base 3, and that's, so we're going to solve it. That's helpful for solving these problems. We can do some things with this one. So still not as complicated as it could be, so we're just using the logs with all the same base, but they have different arguments. How are they all going to be equal? Okay, so the analytic solution here, this says look at the domain of these things. So if we look at the domain, that's where this has to be, these all have to be positive, and the most restrictive one is this would be from -6 to infinity, this would be from -2 to infinity, and this would be 0 to infinity. So the most restrictive one is this one. So that's why they said the intersection of these is this. Okay, so first off, what are we going to do? Okay, so we're going to use those properties of logs where we have one log subtracting another log is a division problem. So I'm going to rewrite this as log of base 3 as a division. X plus 6 over x plus 2 equals log of x, log base 3 of x. Okay, so what does that give us? That gives us that from there. Now this is the main step in solving it. From here we can get rid of the logs. Okay, we can go right from here to this x plus 6 over x plus 2 equals x. Okay, we can go right from that because there's a property that says that, well, they got it written down here. So if the logs of the same base, if they're equal and the arguments are different, then that means those two arguments must be the same. So x must equal y here, and that's what I'm saying here. These are logs of the same base, log of base 3, log of base 3, so these two things have to be equal. Okay, from here, it's just a matter of algebra to solve it. If we multiply both sides by x plus 2, we get some we're going to probably get a quadratic function over here. We're going to get x squared plus 2x. Okay, so that's going to be a quadratic. We're going to solve the quadratic. And here's what the solution looks like. Well, that's what I did on the other page. Typed out nicely. Here's the solution after you do that. Let's get a nice quadratic here. Solve the quadratic. Okay, so the two solutions are -3 and 2. Well, the only one that works here that's in our domain is +2, so that's going to be the answer to our original problem. Okay, so our original problem was back here. Which value of x makes this work? So if we could check that, we could put a 2 here and a 2 here and a 2 here, and right when we get this is 8 and 4, and we do 8 over 4, we get 2 down here, right? That's the same as doing it right here. We would get those two would be equal. Okay, you can also solve it graphically on your calculator. Graph the two functions, right? You graph y1 up here, looks like that, and y2 looks like that. Use the calculator to find the intersection. And notice that the intersection is at 2 like we thought and not at -3, so that was good. Okay, the other type is these where we have logs. These are the same base, equals some number, equals a constant. That's what the k up there means, a constant. Okay, so we're going to apply, since these two things are added together, we're going to write them as products first, right? So we can write log of 3x plus 2 times the log of x minus 1. All that's the log of those two products is equal, because of that plus sign, means multiplication, right, in log form. I'll say though that's still just going to equal 1. Okay, so what do we do now? Okay, so we know that this is common log is log of base 10, and so if we take the log, if we use this to 10 to the power of this exponent, we're going to get rid of the log. So we need to be able to go from log form to exponent form. So exponent form on the left side would just get rid of this log, and it would look like 3x plus 2 times x minus 1 equals 10 to the first power. Now they made it easy by being 10 to the first power, so we would FOIL all this out. 3x squared plus 2x. Don't go yet. And minus 3x minus 2. All that equals 3x squared minus x minus 2 equals 10. To solve this quadratic, we need to get the 10 over on this side. So it would be 3x squared minus x minus 12 equals 0. So it doesn't look like that factors too well that I can think of, but maybe it does. So probably quadratic equation on that one. Okay. So that's what we need to do to solve for x. When we get it to this point, we can solve for x. We know how to solve for x, and we know which x. There's probably going to be two solutions. One of them will work, and one of them won't. We want the positive answer to be our answer. Okay, so this is written out a little more neatly. And they got the same thing, and they solved it here, and it's the plus or minus, right? That's the quadratic equation, exact quadratic equation solution. But we chose the one that's positive because our domain has to be positive. All those arguments have to be positive in a log. Okay, when we have exponents and logarithms like this, okay, so we know the domain of this one has to be look like that. So how do we solve this one? This one, first off, we have to recognize that they have kind of given us a little favor here with this e and this natural log. We know that if we have e to the ln of x just equals x. Okay, so we remember that from earlier lessons. So we can think, well, maybe we can kind of use that here in this problem. Okay, so this.
Evan McAllister to the office, please. Evan McAllister to the office.
Yeah, I love doing my videos here at school. Okay, so where was I? Oh yeah, so I probably want to do something with that, and this 2 here, right? We can use our power rule to go backwards on that. So like I'm going to rewrite that one with the e. I'm going to rewrite e ln of x to the negative 2 power, right? I just put that 2 and undid the power rule backwards equals 1/16. Okay, so now I'm going to use the fact that ln, the e to the ln just equals whatever that is, and so I'm going to get x to the negative 2 equals 1/16. And I know that 1/16 I can write that as a power of 4 equals 4 to the negative 2. Okay, so now we have a situation here where we had two exponents are the same. Okay, so both negative 2, so that means for that to work out, our bases should be the same. So x has to equal 4, right? Because these two bases have to be the same. So this problem worked out to be not quite as difficult as it looked when we first started. Okay, so most of the problems you have will be like that. They contrive them to have a nice solution. Okay, so here it is all written out. And it's not, we could have negative 4 here, but as mathematically, but it's not in our domain. So the answer is going to be 4. And here's a summary of what to do in what situation. 1, 2, 3. If you have it looking like this, if you have an exponent, then solve by taking the log of exponent equals a constant in number 1. Solve it by taking log of each side. Solve these two when it's log, they have the same base. Okay, solve these two functions equal to each other. You may have to move these around so that you get some function that's equal to each other and solve it. And when it's like this, a log, the f of x, solve it by taking the exponent form, right? Take the exponent of this one and of this base to this exponent is going to equal f of x, right? That's what they wrote over here, that this base to that exponent equals f of x. That's changing it back from the log form to the exponent form. Okay, so answer the questions in the form below, and I'll see you guys in class tomorrow.